Um, but yeah, let's get going. So today we're going to talk about evaluating feature stores. We'll talk about the value props of feature stores. We'll talk about the different types of feature stores, and then we'll get into the evaluation. Um, so features are inputs to models. So a feature is just anything, any data point that goes into a model for it to make a prediction. Now, in when we're learning machine learning, we're given these perfect CSVs where each column is kind of a clean, perfect feature. But in reality, features are much more complicated. They're made up of these different components. So the first component is the data source. So typically we start with some source of data that could be CSV, could be a Parquet file, it could be a table, could be a string. Almost always we're going to transform it, likely with many, like a chain of transformations to build the actual feature that we put into the model. At that point, we need it in two places. We need it one for training. So we need to build kind of historical values of these features so that we can train our model. At the same time, if this is a model that's going to go into production in an online setting, we're going to need an inference store. An inference store allows us to do low latency serving. So if I'm making like predictions, if I'm building a recommendation system, I need to know a user's features almost instantly. So inference store is like a cache of the most recent values of features. So this is the anatomy of a feature. But in practice, all these things are stored somewhere, right? Like there is some underlying data infrastructure that makes up what these features are. There's a lot more to this, a lot more to feature stores and features. There are things like streaming backfills, point in time correctness, governance, monitoring, error handling, alerting, audit logs, data deletion, search and discovery. So the reality of what makes up a feature and a feature platform is much larger than just a place where features are created. But we're kind of going to get into this. I want to take a moment to talk about our at Featureform, our view of how to build these features and define these things. Just to give you an example of how this looks in practice. So, like we said, there's the data sources that you build transformations on that will build into your features and training sets. At Featureform, our approach is we let data scientists write their own PySpark code, their own Python, their own SQL, however, to define their features. Featureform then orchestrates that underneath and applies it on AWS, Spark, Redis. And that will actually build and put together our the features so that they're usable. So what we try to do is kind of abstract away to an extent the infrastructure so you can focus on declaratively defining your feature. If you've ever used Terraform, the idea of feature form is essentially Terraform applied to features. Um, it goes beyond just a place to define your features. In defining your features, you get a resource repository where you have your data sets, your transformations, your features, your labels, everything defined. You have collaboration, search, discovery, lineage, share and reuse, tags, and groups, monitoring and alerting, data drift, uptime, and just basic alerting, as well as governance, and finally the orchestration piece. We have native APIs to serve for inference and training, as well as a dashboard to really be able to dig into the features and find the correct features for you. So there are 5 value props of a feature store. There's facilitating deployment, enhancing collaboration, organizing experimentation, increasing reliability, and preserving compliance. So all these come together to kind of be the core values, the core reasons why you would bring on a feature store. So I'll go through these. Let's start with facilitating deployment. So if you've ever been a data scientist from an MLE, you've run into this problem. You have your perfect feature, it's in your notebook, and when it comes time to deploy it to production, you start to realize how complicated that's going to be. And sometimes it's blocking. Like it's actually can be almost impossible to get that feature into production. The way to build a traditional feature is to just like a feature like an experimentation is you work in a notebook or scripts, you're interacting with your data infrastructure, you're pulling together transformations that eventually become features to train your model. In production, however, things are a bit more complicated because when features are deployed to production, almost always the underlying data is changing. There's more data being created, things are changing. There's three ways to handle this. One is via streaming features, where all the new data is being processed as it comes in and then cached in the inference store. There's batch features, which typically run on some sort of schedule. It's like every 24 hours, a feature gets updated. And then there's on-demand features. On-demand features are the concept where features are actually processed at serving time. So, for example, if someone makes a comment on a post and you want to see what the intent of that comment was, you would need to process the text in the comment. So you need to featureize it. The problem is that you wouldn't get that text until inference time. So the on-demand feature kind of fills that gap. The reason why there are these different types of features is the desire to achieve the right level of freshness and latency. So freshness is, well, I'll start with latency actually. Latency is the concept of how long does it take for a feature to get from the feature store to the model. So if you're like using something like Redis to cache your features, it could be super fast. If you're doing an on-demand feature where you're perhaps processing that feature at serving time, that might add some latency. It could take a while. But there's also freshness. So one way to achieve really good latency is to cache. The problem with caches is immediately they are stale. They're out of date. They're not as fresh. For some things, that's not a problem. If you have a feature such as a user's favorite song of all time, that's unlikely to change often. You don't need to kind of process that every 30 seconds. You can probably do that every day or every week or even every month. So the freshness is not equal for each feature, but freshness is an attribute of features which is really important. So streaming features, for example, achieve pretty good freshness and low latency. On-demand features are extremely fresh because they're processed at that time, but they're slow, so the latency is slow. Batch features have similar to streaming features, they're actually quite low latency because they're also being cached, but they're not as fresh. There's also an idea of complexity. Streaming features typically are a bit more complex. There's a lot more error cases that can arise from them. So even though they might seem like the best option, sometimes the simplicity of just building a batch feature is well worth it. So we need to take all that into account as we're going from our notebooks and experimentation to get these things in production. So we need to think about what's the right mode, what's the right type of feature to achieve this. And then we actually need to build that feature pipeline, which is very different because in experimentation, your notebook, if you screw something up, just rerun the cell, you edit it, whatever. In production, these things need to be much more resilient to failure. And the quality bar is much higher. The way I've seen this done in production myself is in one of two ways. Either data scientists themselves write Airflow and PySpark jobs, or data scientists hand off their messy notebooks to data engineering to put in production. So that's facilitating deployment. That's a core value prop. Like that's kind of one of the main reasons you would buy a feature store is to make it easier to get your features into production. But it's not the only reason. Next reasons are also very important. Enhancing collaboration and organizing experimentation. To visualize what this means, I have a few memes for you. So most people, when they're building their feature pipelines in production, those things are changing. There's a lot of stuff happening to them all the time, and lots of time the documentation lacks, if there even is any. Those pipelines that are running production code, that are building your training sets, you can't always understand what they are, why they are the way they are, um, who built them, when they were built. You can look at training sets that you're using and not fully understand how that training set came to be. And those are the problems that you kind of aim to solve. A good picture to really capture this from end to end is, your features are in production, but to get there, you have these untitled notebooks, you have these variables like df final final, you have feature table v7, you have these copy feature to Redis scripts, these ad hoc Spark submits, and to top it all off, you have awful feature documentation, if any at all. So feature stores aim to solve these problems. Feature stores add lineage, add process, add organization to solve these sorts of problems. The last two, increasing reliability and preserving compliance. So increasing reliability is simpler to understand. Once those features are in production, they are live or kind of production code. The problem is that you can never guess what the data is going to do. Data behaves in weird ways. Sometimes things break or change. And unlike traditional software engineering bugs that tend to be very clear, if you have a clear error message, here's what's happened, and you can kind of figure out how to solve it. A lot of the time in these situations, it's closer to like debugging like a race condition, in the sense of it's just much less obvious what's happening. Having things like drift monitoring allow you to capture potential problems before you start to see them in your model. So these are heuristics that you put in place to try to kind of figure out what's happening and try to proactively catch issues, especially with regards to data and features drifting. And finally, there's preserving compliance. I'm not going to go too deep into this today, but feature stores, when done right, should naturally preserve compliance so that data scientists can focus on getting their features in production, working together, while also having compliance enforced across every stage of the lifecycle. There are three types of feature stores. There are three architectures, three approaches to feature stores. When people typically hear feature store, they think, oh yeah, this is where features are stored. What makes sense. I mean, the name is a feature store. So you would assume that it's just a database where features are stored. That is an approach. We call these approaches literal feature stores. So this is the approach that like Feast and Databricks have, where you write your transformations elsewhere, you work on them wherever, and you essentially have a data sync where you write your features to after they've been built. The problem with this is that you don't get any lineage. And all of the complexity that I talked about of building your feature pipelines is not solved by the feature store. The feature store in this situation is just like a sink. It's just a place where the features go after they've been created. It doesn't really solve the problem as a whole. A lot of companies know this, and they've built a lot of internal feature stores. They look like, we call them physical feature stores, where they manage both the transformation and the inference and training store. Now, the benefit here is that now the transformation is tied. So the feature, in my opinion, a feature is the transformation. Like the definition of the feature has to include the transformation to be useful. If it doesn't, it kind of loses its benefit and its value. Um, the physical feature store does this, but it also does this so by unifying your data. What that means is that you have to transform and store your data in the physical feature store. Now, this can be painful, especially if you're bringing on a third-party vendor. You have to now re-platform your data, use a new database engine. And that's why we built a virtual feature store. The virtual feature store sits above your infrastructure. It orchestrates your transformations and provides all the value props that you would expect of a feature platform, but we do it above your existing infrastructure. And that's what makes it virtual, because it's virtualizing the application layer of a feature store on top of your infrastructure. So as you're evaluating and thinking about feature stores, think about what problem you're trying to solve. Do you just want a place to cache features after they've been created? And a literal feature store is the simplest way to achieve that. Do you want a new database engine, like something that replaces your Spark but is built entirely from the ground up for features? Then a physical feature store is your answer. If you're looking for something that's much more about orchestration, about having a source of truth, definition language for features, but you don't want to replace your data infrastructure, that's where a virtual feature store like Featureform comes into play. Like I said, our framework, the way it works is you define your transformations as SQL or PySpark or whatever. The metadata is stored in Featureform, where it is then orchestrated on top of your AWS, Spark, Redis, whatever data infrastructure you use to build and update and maintain and monitor your features. It also provides a dashboard to it provides a dashboard as well to be able to look at the stuff, search things, monitor things, etc. So as you're evaluating, I think there's a few pieces that are really important. I think there's really two concepts around evaluating a feature store. So one is just take these value props, figure out which ones are important to you, most important. I would rank them. Most of the time, facilitating deployment tends to be top. Enhancing collaboration is almost always second. Um, and then think about what it takes for you. So facilitating deployment, like looking at the feature store, does it create streaming features? Does it create batch features? Does it support on-demand features? How easy is it to achieve and build all those things? What's the latency that it has? How does that work for my use case? Does it work in my infrastructure? Does it tie in naturally to my infra? And then does it work in my MLOps stack? I use a lot of MLOps tools. Does it fit natively into those? So like I said, the three types of features, like understanding what it would take to build and update. Updating is really important. A lot of times the feature stores might make it easy to build a feature, but features, it's a very iterative process. So how easy is it to iterate on the features that you built? Batch features, scheduling, like how does scheduling look? How can I build and update batch features? And then finally on-demand features. Latency. So latency is a big piece here. Typically, latency is going to be tied into some larger product or component. For example, if I have a recommendation system that puts recommendations on my homepage, I might have this latency budget for getting the homepage processed. Now, there's backend latency, there's client latency, and then part of that latency is going to be the machine learning latency, and there's going to be a budget there. And for that budget, you're going to want to break it down into two parts. There's the feature latency and the model latency. Sometimes the model is the really expensive part. Sometimes the features are the expensive part. But in general, you kind of add them together to generate your ML latency, the system's latency. And so thinking about what's the actual feature latency I need to achieve is really important. A lot of people kind of assume faster is better. And sometimes that's true. I mean, if you can freely get something that's faster, then why not? But a lot of the time that speed comes at cost. So kind of finding a sweet spot for you. What is like well safely within your budget? Um, and does the feature store that you like most achieve that? Feature stores are one component of the MLOps stack. There's small experimentation platforms. There's deployment. There's other like ML monitoring tools. There's platform level things, Kubeflow, Flight, etc. There's stuff underneath it. Like there's Redis and Spark and Snowflake and Cassandra and Kubernetes and there's on-prem and there's all kinds of parts to the stack. Another key component is figuring out how your feature store would fit into that stack. How clean does it fit in? Does it natively integrate into all the different pieces here? Now, a lot of people focus on the facilitating deployment. Almost all of the questions we typically get when people are evaluating start there. How fast are you? What's your latency? Do you deploy here? Um, that's a huge part of the problem of the thing to solve. But my sense, what I've found, is that MLOps problems are organized into two different spaces. There's the engine problem, which is like how fast is this thing? Does it handle this much data, etc. And then there's the workflow problems. That's things like versioning, lineage, organization, sharing, governance. Everything that's much more people problems, like people interacting with each other, managing data scientists, having data science teams work together cohesively. Those are workflow problems. A lot of people focus on engine problems. And engine problems are extremely important in the sense of if they're not solved, then the workflow problems almost aren't as important. But if you solve the engine problem, then almost always, like making something faster when it's already fast enough is not as valuable as focusing on the workflow and getting people to work faster and iteratively and collaboratively. We have this metrics pyramid, and I think it's a good way to think about this. At the lowest level of the pyramid is the infrastructure reliability and metrics. These are things like latency and throughput, uptime, etc. This is key. Like if you don't have that, if you cannot achieve the latency you need or the uptime that you need, then nothing else matters. That becomes top priority. Once those things are achieved, the next focus becomes iteration time. Are we putting out features that are breaking systems? How fast can we get features in production? How fast can we iterate on those features? So these become the next level of metrics. And then on top of that, finally, there's the adoption metrics, the product metrics. How naturally does this fit into my workflow? Do I like using it? Like, do data scientists, ML engineers like using the feature platform? How native does the API feel? You can have something that achieves really high latency, that is in theory very iterative, but the API might be so hard to use or so just unnatural for the workflow that no one uses it, or people go out of their way to not use it. In that situation, you kind of lose the benefits of the bottom two rungs. So, in my opinion, once you kind of get past the deployment piece of evaluation, can this thing run here, here, here? Does it fast enough, etc.? The focus should be on the API. How nice is the API to use? Do our data scientists enjoy using it? That's what's going to be crucial and key, and a key differentiator. And in my opinion, that's where a lot of the focus on the evaluation should be, not on benchmarking and speed, which you should do, but much more on the API design, the flow, the iteration. That's going to be what really separates out feature stores from each other. Because in practice, almost every feature store is going to be fast enough for you. It will, a lot of feature stores handle different types of infrastructure, but the APIs and the workflows are drastically different. That's where they really differ, and that's where, in my opinion, you should be evaluating. Um, awesome. So that's all I have for today. So a bit of a short webinar. If you have any questions, you can throw them in the Q&A on LinkedIn and Twitter. Like I said, you can throw them in the comments and I will be able to answer them. I'll try my best to at least.
Cool. And I'm looking at LinkedIn too. So if you're on LinkedIn watching it, I can pass your questions along to Simba.
Awesome. Well, as we wait, maybe people are writing in their final questions. Marie, maybe you could tell everyone what happens from here or the email you'll send after.
Sure. Yeah, so after this, I'll send all the attendees an email with the webinar recording. I'll also send links to our docs. So if you're using the open source version of Featureform, you can check those out. And a link to our Slack community. So you can join that. You'll be able to talk to our team in case you need to troubleshoot, and also connect with fellow MLOps practitioners. Awesome.
Great. Well, I don't see any questions. If there's none on LinkedIn, we can sign off. If you have a question that comes up later, I'm easy to find. You can find me on our Slack community and ask questions there. You can always email me. I'm just Simba at Featureform. But otherwise, I hope this is useful. And yeah, thanks for making some time this morning to hang out with us.